Hi guys, welcome to week 6 of our lecture. In this week, we will discuss on comfort and health, which involve in the indoor environmental quality when you place HVAC system in a space. So other than just designing, knowing the cooling load, knowing the heating load, knowing the cooling element, heating element, what is the relative humidity, so on and so forth. It's also imperative for us to know what is the most important thing other than designing, which is health and comfort. So we are going to discuss further and focus on human health and comfort, right? So let's visit our times page. What you're looking right now is, as you know, is our times page, air conditioning and refrigeration engineering. So let's go straight to lecture 6. So lecture 6 is our lecture for today, in this video, entitled Comfort and Health Indoor Environmental Quality. So please have this slide, PDF slide in your device, so we can use this to discuss together what is environmental quality, indoor environmental quality, which promotes comfort and health for human. Okay, so welcome guys to our lecture 6 or week 6 lecture, comfort and health, indoor environmental quality. In some of the aspect of indoor air quality, indoor environmental quality, how are we going to design a space other than just calculating the cooling loads, the heating loads, the appropriate temperature, the comfort zone? What are other aspects towards comfort and health for human being to be in an air-conditioned space? As you all may know, air-conditioned space is quite cool and quite comforting, but after a while, it's not very healthy to stay indoors all the time. So what are the decisions expect for us other than, of course, going outdoors and take a breath of air, fresh air? What are other aspects that promotes the comfortness and also health inside a air-conditioned space? Alright. So our chapter details will be 2 parts. First one is comfort. We will talk about air indoor quality, comfort condition, and second part will be health, common contaminants, or what are the particulates or contamination that is common in the space, health effects of air pollutant, and last one, what are the methods to control humidity and contaminants. So these aspects, not just to give us comfortable condition in a space, but also to give us health. Okay, so as you may guess that this week there are not much calculation in the context of comfort and health. The only calculation will be how are we going to add or reduce cooling loads or heating loads appropriate in order for us to stay comfortable inside a space. Now let's go for the first one, the comfort condition. Okay, comfort is the absence of discomfort. Of course, it may sound so trivial, but it is very important. What is comfort is the absence of discomfort. And what is discomfort? Now, before we go, not everyone have the same idea of comfortable in a same plane, right? For example, those people who live in the US might say that summer in the US is quite hot. But if we go to summer in the US, you feel, hey, it's just like in Genting Highlands or Cameron Highlands, where the sun shines, but the air seems quite cold, right? So comfortable or comfortness or discomfort is different based on perceptions of human being. Thermal and atmospheric conditions in an enclosed space are usually controlled in order to ensure the first one, health and comfort of the occupants that stays indoors, the proper function of sensitive electronic equipment, For certain manufacturing process, they have limited range of temperature and humidity tolerance. That means sometimes not just people who are going to sit in that room, sometimes you will have electrical equipment, sensitive equipment, maybe high grade computing workstation, so on and so forth. And also we want that place to have certain amount of temperature and humidity, and the tolerance is very small. So this is another aspect of indoor environmental quality. The former, which is the sensitive electronic equipment, referred to as comfort conditioning, and latter is called process air conditioning. The condition required for optimal operation of machinery may or may not coincide with those conducive to human comfort. What does it mean? The condition of human to stay indoors in an air-conditioned space will be different than the one that you miss. Let's say there's a computer servers for Amazon, for Apple, for Google. They're quite different. Usually, these rooms are very, very cold, right? Very, very cold. So it is not comfortable for us, but comfortable for the machines. Okay, the total comfort, which is the total overall comfort in IAQ, it is based on an ASHRAE standard 55 1992 thermal environmental condition for human occupancy. It divides the IAQ to two parts, the thermal comfort and health. So we talk about comfort just now. Now we go deeper, which is not just comfort but thermal comfort. Right, thermal comfort will lead to physiological health of a human being, and other than that, it gives a perfect biological environment, also chemical environment that keeps us in good health. What does it mean by biological and chemical? For example, the air that you breathe in, are they really fresh? Or what are the percentage of carbon dioxide in the air that you're breathing? Or what is the percentage of oxygen in the space or air that you're breathing in? The higher the carbon dioxide, for example, will promote sleepiness. That is why if you stay in a room that is air conditioned and it's not really well ventilated, you might feel a bit sleepy. Not because you just ate a lot of food during lunch or you are tired, but sometimes your brain is deprived of oxygen and you feel sleepy, right? So HVAC system control the thermal comfort of a space, and in turn psychologically and physiologically control the health of human being by biology or chemical. Alright? Next slide. Why should we care about comfort? The first one, health and well-being. Many thermal comfort condition can cause health problem. Alright? For example, let's take back the carbon dioxide. A high percentage of carbon dioxide is hazardous not really to human life, but hazardous to the condition that this human is staying in. For example, if you want to stay in a, let's say in a classroom, you don't want to be very sleepy, right? So high percentage of carbon dioxide is very hazardous if you want to stay alert in a space or air conditioned space. Okay. If you have a good comfort place, of course you will be optimized to do work or study or maybe just playing games, right? Playing games, leisure, if I would say. Improve perceived quality of life. Usually if you have a conditioned space, you will feel healthy, you will feel wealthy, because the comfortness is enough to say that I am happy today. Okay, so what is our next slide? Now, environmental condition affects thermal comfort have a few primary factors. We have metabolic rate, clothing insulation, air temperature, radiant temperature, air speed, and humidity. The first one, metabolic rate, will discuss on what kind of activities of a person, personal factors that have inside that room, right? Are you in a gym? Are you in a classroom? Are you in your bedroom? Are you in the dining room? What are the activities that is happening for the person who's staying inside that place. Clothing insulation will talk about what type of clothes that you are wearing. If you are inside a very cold temperature air-conditioned room, it is not advisable for you to wear very slim clothings, right? You must wear very thick clothings. But in terms of comfort, sometimes the difference or the balance between wearing not too thick clothes, not too slim clothes, compared to the temperature of the surrounding inside the room, and also compared to the speed of air that moves from the aircon out and in, they are also contributes to the clothing insulation. And also other than that, it will contribute to the air temperature inside that room, right? Radiant temperature will talk about the sunlight or sun rays, because sunlight have infrared and UV. These two will increase the temperature inside the room. So radiant temperature will discuss about sun radiation. Airspeed, which will talk about the speed of air that move into that room and out. And of course, lastly, the humidity factor. So the first two are for personal factor, that means human factor, and the last four are the non-uniformity of a body, that means it's general. The first two, metabolic rate and clothing insulation, are preferable. Some people prefer to wear very slim or skimpy clothing, right? So they don't really need cool air-conditioned space. Or some people are not going to stay in the gym while at the same time it is very hot, right? It's very hot. So it must be a balance between these two factors. Right, thermal comfort. Oh, where did it go? Alright, thermal comfort predictive model is designed by ASHRAE, or the pioneer will be Professor Fengers, and his famous methods were comfort equation methods, which is the heat balance method, links environmental condition to body thermal load. These talked about the calculation that we have done. Predicted mean vote method, or PMV model, links body thermal load to thermal sensation scale. This one is survey. So if you go in about a room where you have designed the room based on your calculation, but you really want to know what are the aspect of people that is staying inside that room, what do they really feel? So you give out a survey, and they fill in a survey saying that, oh, actually, I'm not comfortable in this room. This room is humid. This room is not humid. It's dry. It makes my skin dry, right? It makes my face wrinkle, for example. Right, the last one is predicted percentage of dissatisfied. It's similar to this predicted mean vote. This one agrees to what you are having inside that space. The third one, predicted percentage of dissatisfied, means what you don't like about the space, and you do the survey. So the standards that we are using are the ASHRAE standard. So we have a few years, maybe the latest one will be 2019 or 2018. Okay, thermal environmental condition for human occupancy, majority it was written in the 2004, and also ISO standard 7730 entitled moderate thermal environments, determination of PMV and PPD indices, and specification of conditioned thermal comfort. Alright, the thermal scale sensation. So this is the survey that I talked about in a few minutes ago. PMV, or predicted mean vote index, predicts the mean response of large group of people according to ASHRAE thermal sensation scale. So this is the scale that ASHRAE has set. The first one is 0, will be neutral. If it goes higher, +1, 2, 3, slightly warm, warm and hot, and we will go negative, slightly cool, cool and cold. Alright, so we will put this in the survey, and people will tick where does he or she inside that room feel at that moment. Acceptable range of operating temperature and humidity for people in typical summer and winter clothing during light and primarily sedentary activity less than 1.2 Met are given in the figure. Now let's talk about this lightly. We will discuss these terms in depth in a few slides after this, but the introduction will be Technically, this question is always given to those who are living in a temperate climate. Are they in summer? Are they in the winter? What kind of clothes they are wearing during these two seasons? What are kind of activities? Sedentary means you just sitting down, watching TV, playing games. There's strenuous activity like gym, workouts, or so on and so forth inside the room, right? This MET means less than equals to 1.2 MET. MET stands for metabolism of a body. So 1.2 is a characteristic of a certain activities that promotes low metabolic rate of a human body. Right. So once these votes are collected, it will be compared to the one that you have calculated before in lecture psychometric chart 1 and part 2. Right. For 1.2 MET to 3 MET, between these two, the metabolic rate of a human being or person that stays inside that room will be given or superimposed in this comfort zone psychometric chart. This is a part of the psychometric chart where in English unit it's 75 degrees Fahrenheit. I think more or less it's 24 to 26 degrees Celsius. Between these will be the best or perfect states in your air conditioning system. For example, if you are in the winter, right, this is your place. Your comfort zone will be somewhere in the middle here. If you are in the summer, your comfort zone will be also in the middle here. So these zones, we'll talk about the comfortable place or zone is either within summer or winter that you're going to be very comfortable. So along this line, right, you see my laser pointer there, will be the perfect, nicely conditioned space. Right, between 75 or 26 degrees Celsius, the humidity ratio should be between 5 per 1000 dry air to around more than 10. If you go higher, then it will be very humid. If you go lower, then it will be very dry. If you go this way, it will be very hot. If you go to the left, it will be very cold. If you go to the high place, also the relative humidity will increase. If you go downwards, the humidity relative humidity will be decreased. Right? Having a relative humidity decrease means you are taxing your air conditioning system to suck out air from that space. That means more energy needed. The higher you go, the less energy is needed. But the higher you go, then there's more energy needed to maintain a comfortable conditioned space. That is why it is imperative for you to stay at a certain temperature at all times with a certain relative humidity and certain humidity ratios and others as well. The acceptable operating temperature will be given by this equation. T, or temperature active, is equal to T at sedentary minus 5.4 and 1 plus clo. Clo is clothing. There's a number for clothing as well. And metabolic minus 1.2 times F, right? If your metabolism is 1.2, this whole section will become 0 and T active will be equal to T sedentary, so on and so forth. Acceptable operating temperature in degrees Celsius will be this equation. So this is for English unit, this is for Fahrenheit. Right, activity level. Activity level is about human body, the activity that a human body is doing. I'm not sure my English is correct right now. Human body continues to produce heat because we are burning food or fuel. So the metabolism that you have in your body promotes the heat that is released into the space. So heat that must be emitted from the body to maintain fairly constant core temperature of your own body, so you will not feel sick. You feel very comfortable, and ideally a comfortable skin temperature. Right. The activity heat at minimum rate when you are asleep, or as activity increase from sitting to walking to running or to strenuous exercises, the metabolic heat produces will also be increased. So this standard is called MET or MET. 1 MET is the metabolic rate or heat output per unit area of skin for an individual who is seated and at rest. So how much heat is produced and released from your body must be sucked out by the aircon system and pushed out from the room. Then you will feel comfortable. Typical activity levels and corresponding MET values are shown in the following table of standard ASHRAE 55, which is this one. Okay, resting is also sleeping, reclining, seated quietly, and standing relaxed. Walking 0.9 meter per second, 1.2 meter per second, 1.8 meter per second. Or office activities, sitting, reading and writing, typing, filling, or filing while seated, filing while standing, walking about, lifting or packing. So I'm not kidding here. So MET unit are given as such, as you can see here on the slide. The metabolic rate, you can put this into the calculation, right? We'll talk about this later. In SI unit, and this one will be in English unit. On the next slide, we talk about the clothing. Another determinant of thermal comfort is clothing. In the majority of cases, building occupants are sedentary or slightly active and will wear typical indoor clothing, shirt, tie, slacks, right? Or if you are in a new hipster offices, you will wear a very thin sweater and t-shirt and jeans and also shoes, okay? Lightly clothing. Clothing, though its insulation properties, it's an important modifier of body heat loss and comfort. Right, if you are in a cold room, you cannot wear slim clothing. If you are in a hot room, you cannot wear winter clothing. So it's very important. Clothing insulation can be described as CLO, C-L-O value, which is given as this. Trousers, short sleeve shirt is 0.57. Let's see, knee length skirt, long sleeve shirt, half sleeve pantyhose and long sleeve sweater contributes 1.1 CLO number. Right, or value. The CLO value is a numerical representation of clothing ensembles of thermal resistance. The thicker of your the thicker clothing that you wear, the higher the CLO value. 1 CLO is almost equals to or is equals to 0.88 feet squared times hour Fahrenheit or BTU in a bracket 0.11 meters squared degrees Celsius times watt. Okay, so the next slide is showing some kind of clothing. This one is very slim clothing. It is labeled 0.2 CLO. Office attire is 0.8 CLO. A thicker office attire will be 1 CLO, and a very thicker clothing will be like this, 3. Alright, next slide, we talk about airspeed. What is the airspeed that moves into the room given out by the aircon system? ASHRAE book 62 in the year 1989 talk about the objective of ventilation or its satisfaction of 80% of inhabitants. So if 80% of inhabitants inside the room is satisfied with the airflow inside that room, then they will say that the room is comfortable, right? Generally accepted safe limit is 0.5 concentration of healthy, sedentary, and occupants eating a normal diet. Right, so these 3 are the main aspects when we talk about airspeed. Of course, people who are sick, sometimes they require higher airspeed, sometimes require low airspeed. So it depends on the condition of occupants inside the room. Airspeed allows for individual to vary in health, eating habit, and activity level. So I'm not joking. Airspeed is very important for you to stay healthy. Sometimes the room is hot, but when you switch on the aircon, it's quite cold. But you blast this cold air straight to your chest. After a few hours of exposure, sometimes people can develop flu symptoms, right? Because the core temperature body reduces, and as core temperature body reduces, the body enzymes and also chemical properties will drop, and usually when it drops, viruses and bacteria will become stronger. So that is why some people can catch cold if they stay in a cold spaces, right? Example of air motion The effects of air motion in the summer comfort zone is given by this psychrometry chart diagram, right? The higher temperature in the summer, the comfort zone extended towards the right. That means it becomes wider. So as it becomes, it's not just this box. This space become wider and wider, and therefore calculus says the more area under the graph, the higher the work it will be to cool down the space. So if you are staying in a very hot climate, usually you are required to use more electricity to run the aircon, right? So more energy is needed if the area graph is increased. Okay, so as you increase the air motion, sometimes you are increasing the comfort zones as well. So the higher the fan speed, sometimes the higher the energy used to run this air conditioning space. Now take a look at this slide, the example of effects of air motion. The graph that this laser pointer is showing shows the airspeed required to offset increased temperature. So as the temperature increases, down here is degrees Fahrenheit and up here is degrees Celsius. As temperature increase, the airspeed, this left is FPM and the right side is in the SI unit, meter per second. The air will be needed to be increased. The fan works should be increased to supply cold air even faster inside that room, right? The higher the temperature, the higher the airspeed needed in order for us to bring in cold air around and surround the room. On the right graph, it shows the optimum operative temperature for active people in low movement environment. So velocity is less than 30 feet per minute or less than 0.15 meter per second. Right. Have a look at this table. They have for clothing. This is operative temperature in Fahrenheit. This one in operative temperature in degrees Celsius. And these are the activity levels or the metabolic rate that is happening. So towards the right, we are going to be very active. And as you can see, the clothing number drops. So the more active you are, I would say that this is very vulgar, but the less appropriate clothing that you will wear, right? People at the gym will not wear winter clothing, so they wear maybe tanks or tops, or maybe easy dry clothing, so on and so forth, right? But a similar clothing cannot be used in the metabolic rate, which is less than 3. For example, here 1.5, 1.2, sedentary activities, right? You cannot wear this kind of clothing because you'll be very cold unless your working office doesn't have aircon and you will work on your own bed in your own bedroom beside the seaside, so on and so forth, right? So we are talking in the context of a room that is air conditioned. All right, now next, radiant temperature. Radiant temperature is the heat that is transmitted from a hot body to a cooler body. So technically, maybe we are talking about the sun rays, or maybe you are staying beside a place where it radiates a lot of heat, right? There is no effects on the intervening space. That means between the spaces that you have inside that building, there's no effect between on the intervening space, right? So maybe this room is directly facing the sunlight. For example, radiant heat transfer occurs when the sun is shining on you or shining on the wall of your outside of your house. For example, you are staying in a room and your friend is staying in a room on your right. The sun rises on his or her place and sets on your side. That means your room is facing the sunset. Then it will be very hot compared to your friend who was staying in a room which is facing the east. The radiant temperature is a temperature in which a black sphere would emit as much radiant heat as it receives from its surrounding. So this is just an imaginative or mind experiment. Like if you have a black sphere, of course black sphere will absorb most heat because it is black. It absorbs heat or radiation, right? An occupied space may be at a temperature that is very close to the air temperature of the floor, walls, and ceiling, right? Your floors, your walls and ceiling, especially in temperate climates, winter and summer countries, these three items must be well conditioned, especially the floor, right? So you don't want a very cold floor in a very cold winter, then you step on it barefoot, right? Either you wear stockings or socks, or you will use water-based air conditioning system that we have discussed in lecture 2 or 3, right? For internal space, where the temperature of the wall, floor and ceilings are almost the same as the air temperature, the radiant temperature will be constant in all directions. That means if your walls, your four-sided walls, your floor and ceiling are almost the same temperature of the air that surrounds it, then we will consider it to be constant in all directions. Sometimes you can have your floors will be very warm, but your walls are very cold. That means heat will radiate from the floor to you, to the surrounding and to the walls, right? We have houses that is designed this way to reduce the loading of cooling load of the aircon system, right? When a person is standing or sitting close to a large window on a cold, cloudy winter day, the average radiant temperature may be slightly lower than the air temperature. That means, what is the situation? Let's say the walls, the floors, and the ceiling have different temperatures. If you are standing to the window, those people who are staying close to the window will feel very cold or very warm compared to the ones who is staying inside or in the middle of the room. Similarly, the space in which radiant floors or other form of radiant heating, the average radiant temperature will be above the temperature during the heating season, right? Operative temperature. Some people consider operative temperature is the wet bulb globe temperature. So dry bulb temperature is the condition that we are referring to as direct latent comfort. If the room is 30 degrees Celsius, it's hot. If the room is 16 degrees Celsius, it's cold. So this is we call as dry bulb. The operative temperature is also called as wet bulb temperature. So in the psychrometric chart, you have your wet bulb. So this is your operative temperature. It's a composite temperature used to estimate the effect of temperature, humidity, wind speed, and visible and infrared, usually sunlight, on human, right? Operative temperature is the same as dry bulb temperature if there is no radiant heat. That means if there is no radiant heat, right, your room does not have any windows and your walls are not facing any sunlight, so your operative temperature will be the same as dry bulb temperature. But if your room is not like that, so wet bulb temperature, or which is usually colder than the dry bulb temperature, will be your operative temperature, will be the temperature that is working on you. So this is another view of temperature other than just the simple temperature, dry bulb temperature, that we have discussed in previous lectures. The operative temperature also plays a major role in for you to stay comfortable. The equation is given by T to the power 4 and labeled MRT for mean radiant temperature, equals to Tg to the power 4. G is for globe temperature, the surrounding temperature. C is this constant. V is the air velocity, either in feet per minute or meter per second, right? A is then ambient air, either Rankine or Kelvin. That means you must use ideal gas approximation. Okay, example of operative temperature. Determine the operative temperature for a workstation in a room near a large window where dry bulb temperature and globe temperature are measured to be 75 degrees Fahrenheit and 81 degrees Fahrenheit respectively. The air velocity is estimated to be 30 feet per minute at that workstation. Solution is to use this equation, right? And then you put in your values. Tg is your globe temperature times 460 to change from Fahrenheit to Rankine, and you put all the values there, and the T mean radiant temperature is 86 degrees Celsius, right? And then To know what is your operative temperature, we put it inside this equation. TMRT plus TA. TA is the original air or dry bulb temperature, divided by 2 to find the average of these two. It is around 80.5 degrees Fahrenheit, or sometimes the Americans like to approximate it to be 1 digit or 2 digits, like this is 81 degrees Fahrenheit. Alright, so that is air indoor quality that talks about the comfort inside a room. Now we will talk about the health condition aspects of thermal comfort. Alright, in this aspect we will look at the health of occupants inside the conditioned space. Humidity indoors is our first aspect. Indoor humidity is a function of outdoor humidity. Indoor sources: unvented cooking, unvented bathroom, showering. How many occupants inside the room? Do you use a humidifier? Do you use air conditioning system? Do you have clothes drying inside the room, either mechanical or air drying? So these aspects, indoor and outdoor, and all these sources of indoors will contribute to the humidity indoors, because sometimes even though outdoor air have very dry humidity, the air that is inside the room, which is maybe high humidity, the humidity will go out from this room, from the room towards outside. If outdoors have high humidity, then humidity will go inside or indoors. Let's say that you're currently in at noon, it's very dry outside, your room will become very dry as well, as humidity moves out from your room to outdoors. Unless if it doesn't have a way to move out, maybe you close the window tightly, the humidity will remain and you'll be very uncomfortable, right? Sometimes if the outdoor air is maybe you're going to have rain, or it is raining now, the humidity will be 100% outdoors and it will seep into the room, and the room will be humid as well. Right, so those are the often magic issues on the residential building. So this slide will talk about the health issue that is affected if you have high relative humidity. Directly, usually some of the sensitive people will have eye irritations, you have respiratory or asthma, you have dermal issues such as skin dryness, and you have trouble to have a comfort perception. Or indirectly, biologically, when the room is very humid, there will be a lot of dust mites inside the room. At the same time, it will be molds. At the same time, you have cockroaches, because cockroaches love cold and damp spaces. You have infectious agents like viruses and bacteria also live and thrive in humid climate or place. Chemically, the room is high in ozone. Ozone is very toxic, right? And also formaldehyde as well. In this slide, talk about the methods to control humidity. So what you're looking at is the one that you're very used to seeing. This is called the it is called the humidistat, right? In extreme humid outdoor condition, or large requirement for outdoor makeup air, or high ratio or internal latent to sensible loads such as indoor swimming pool, you may require special dehumidification, right? Sometimes your air conditioning system is fitted with a humidifier or dehumidifier. In this case is refrigerant dehumidifier. That means you remove the liquid inside the room, so you will have lesser temperature and also lesser moisture or humidity, right? Or sometimes you use surface or liquid desiccant. That means this form of calcium carbonate suck out or suck in humidity from the air. That it is likewise the one that you have in your medicine bottles, yeah, your vitamin bottles. Right, humidity reference dehumidifier used to lower the supply air temperature. low enough to remove required amount of moisture, and then you reheat it back again to desired temperature. So you reduce it in order for you to use or to reduce moisture. As you can see, this is a warm humid air. You reduce it using maybe an ADP, the dew point apparatus, right? You reduce the temperature. You see, it's straight this line, and drops, and it reaches the 100% RH will drop again, and then it will just be heated up again. That means the air is hotter but less humid, as you have removed the humidity using ADP. All right. Using recovered condensed heat or other waste energy makes this process economical. So to increase this, sometimes you use heating element, which is quite expensive, right, compared to not using it at all. Or you can also use heat or other waste energy. Maybe the hot place that it is inside the room, you supply into this and mix it into this air duct, or any waste energy. For example, if you have a space or a machine that have a high speed air and also very hot and dry, you can supply it into this ducting system as well. Why? It is cheap to produce, easy to operate, effective in most domestic and commercial applications, perform exceptionally well in if you use it in warm, humid condition, and lastly, the performance is directly related to the difference between the air dry bulb temperature and the air dew point temperature. If you use a Desiccant humidifier, you install this at the air intake or the reactivation air, you will suck in moisture indefinitely as well, rather than use a heating element or waste heat from somewhere else. You use a Desiccant humidifier. It is equipment that operates in total different principle of a refrigerant type. The main benefit of a Desiccant humidifier are perform especially well when used in cooler climates or when you have low dew point is required, high latent to sensible heat ratio. The cost of energy to regenerate the desiccant is low in compare with refrigerant. Air must be delivered continuously at sub-freezing temperature. It can remove other contaminants at the same time of humidity. That means you must have this placed in a very cold climate, which is very cheap. Okay, so the graph doesn't really match. Right from here, you increase it, and then you reduce it, but you increase the humidity as well because you absorb. So this part is the absorption. So the cool humid air will become warm and dry air as you use this in the cold climate spaces. Alright, I know that this picture is quite vulgar, right? I take this from Ashley Handbook. So you might see it positively. Okay, the fuel that you eat will contribute the high metabolic rate. If you do a high metabolic exercises or strenuous activity, you exhale warm air and moisture gases. Your body is also produce evaporation. There's natural convection at your body. Radiation, you release heat, and forced convection to cool down, and also conduction if your floor is cold or warm at the same time or at different times. Okay, so this is the table where you should have your relative humidity as perfectly as possible. So if this is our temperature at using Fahrenheit, so let's say 76 is our comfort zone. Higher than this, you must increase or reduce the relative humidity. Let's say 110 degrees Fahrenheit, relative humidity is very high, right? If you reduce this, you will also reduce the temperature. Okay. Now, indoor air quality will talk about the indoor spaces such as residential, offices, healthcare facilities, and others that you have air conditioning system inside that space. Another aspect of indoor air quality is called the sick building syndrome, which is not really discussed heavily in this module because it is very extensive and it involves a lot of surveys and inspection inside the space. Other than dealing when we are designing a room, sick building syndromes try to resolve issues as the room has been built. Originally, buildings that we have here in Malaysia, they are built either during the 70s or 80s or during 90s. At this period of time, air conditioning system is not really what is important in the aspect of developing or designing the structure of the space, right? So you will have a lot of gypsum boards, GYPSUM, gypsum, or the wall or ceiling which is made of asbestos or other materials that allow mold to build up. For example, that one you see on this picture sometimes has adverse effects on human health. So indoor air quality is what is the term that is given to this study. So it is a term referring to the air quality within and around buildings and structures, especially as it is related to health and comfort of building occupants. It is important that because average people spends more than 80% or 90% of their life indoors, other than sleeping and living or doing exercise. Most of us stay indoors. Studies have shown that indoor air may be 10 to 1,000 times more polluted than the outdoor air because of the dust and the mites and the molds and the whatever the viruses and the bacteria and the fungus that live and thrive in that closed space is usually higher higher compared to the one outdoors, right? Because the air is not moved out of from that air and because air and liquid or humidity does not go out from that space, right? There are two main categories. The one that I've spoken about just now, the building related illnesses where the specific diagnosis can be made, including identification of causative agent. What we do is we break down the building materials and change for a new one. So it is called a sick building syndrome, which is defined as persistent set of symptoms occurring in greater than 20% of building occupants. That means majority of the people inside the room have a similar symptoms that cause sickness, right? With no readily recognizable cause. So what we'll do, we give them leave and we tear down the building or the space and make it as a new one. The sick building syndrome symptoms are headache, nausea, dizziness, coughing, muscle pain, and fatigue. This is just like if you are infected with viruses. Yeah. Sources indoor pollutant will be combustion activities outdoors, the furniture, maybe the furniture gives out, chemical, building materials, food, smoking activity, and outdoor air pollution. Right. So let's give names to these indoor pollutants. The first one is carbon monoxide. Right. The organization that looks at it is EPA and PAAQS. This organization limits it must be around 35 ppm as 1 hour average. That means in 1 hour around 35 ppm of exposure is allowed. Or if you are from SIAQG, find it yourself in the internet, you can have lesser than that, 9 particulate per minute of an 8-hour average. Carbon monoxide, ventilation, air exchange rate to achieve carbon monoxide must be below than 1000 ppm, right? This one is governed by ASHRAE and SIAQG. Right, if you fun facts, do you know why that you are sleepy when you drive your car? Right, when you close your the windows, when you close the air vent, and just to let the air circulate inside that cabin of yours, the carbon dioxide will overshoot more than 5,000 rpm. Sorry, 5,000 ppm. So we're talking about cars. 5,000 ppm. That is why the carbon dioxide inside the room is quite high, and because you are deprived of oxygen, you feel very sleepy and it's very dangerous to drive at that condition. Right, so you can read the rest of the indoor pollutant on that slide. Yeah, air pollutant and contaminants are unwanted airborne that may reduce acceptable of air. Some contaminants are brought into the conditioned space from outside. Some are generated within the space itself. So you can learn these contaminants like allergens, bacteria, virus inside this table yourself. Yeah. Alright. On these slides, we talk about more on the air pollutant and contaminant. The parameters, the room temperature, also is a contaminant. The high temperature, the high relative humidity, the high air movement also contributes to a place which does not have a good, comfortable space, right? Method to control. The first are 4 basic methods to control gaseous or particulate contaminants. The first one, the source, elimination or modification. Find the source and eliminate it and change it. Use more outdoor air. I mean, don't circulate the air very much. A good space air distribution must not have a blockage. For example, there shouldn't be any obstacles in the front of air flow from the air conditioning system, right? To ensure that there is a good flow inside there. Right, and the last one is to have air cleaning. Right, source of elimination and modification. What you can do, it is the most effective method since it operates directly on the source. New design or retrofit buildings, usually the care is to remove the condensation, leakage and growth of fungal because they are new, right? They are new. And of course, when you have new building, you have a lot of formaldehydes in the paints, you have a lot of asbestos, fiberglasses that is inside that room, which is very harmful to your lungs. If you have existing building, finding and removing the source is most important. Eliminate of smoking and have a designation of smoking zone. No storage of paint, solvent, volatile components within the building, but you must put it outdoor in a space where you call a storeroom. Mold and moisture in the building must be removed either by placing or replacing the infected places and components, or if not, the building should be abandoned as the problem seems to be beyond solution and eliminate the whole thing. The use of outdoor air, the second one, is outdoor air is taken from the external atmosphere, used to dilute contaminant within the space. You can also purge it from the space. You purge out the contaminant and take fresh air inside, right? However, infiltration does not consider as outdoor air. Infiltration means, for example, if your door is not tight shut, right? There's a gap between your door, between your window, the cracks of the door, cracks of the wall that leaks out the cold air, precious cold air from the room. These are not outdoor air. We consider as leakage or infiltration. It is assumed that outdoor air is free of contaminants that might cause discomfort and harm to human because the outdoor air is very, very large space, right? Unless you are living in places that is very packed in population, high in pollution, then this might not be a very good idea. Okay? If strong contaminant exists near the building, the air surrounding the building may not be free of contaminant, just like what I said just now. The supply rate air must exceed the return air. The conditioned space will be pressurized relative to the surrounding, right? That means the space must have the same pressure outdoors. So therefore, there will be no infiltration between the indoor and outdoor or outdoor to indoor respectively. Exfiltration leakage will occur to provide balance, right? Sometimes you leak out air rather than leak in because you have high pressure in the room, the air will leak out indefinitely. So this is very useful, like in the hospitals, the corridor usually have lower pressure than the one inside the room. So when nurses and doctors open the room, air will rush out from that room because of difference of pressure and will bring out contaminants as well, right? It is harmful if particularly deadly bacteria exists in the space. So we must use fresh outdoor air. to combat this, right? If the return air exceeds the supply air, the space will be at pressure below the surrounding. Infiltration will occur. That means air will seep into the room, right? This will be particularly bad in the case of clean rooms. Clean rooms means this space where you design what you call that, CPU chip, right? Those high sensitive equipment called clean rooms. Also for operating theaters, right? So the equation, which is very simple, QT plus QC plus N dot equals to Q dot T and CS. QT is the rate of air leave or enters the temperature, the space. C is the average concentration of contaminant within the space. N is the rate of contaminant generation within the space, right? How much contaminant is generated. And the last one, CE, is concentration of contaminant interest of the entering air. So let's do one example. A person breathed out carbon dioxide at a rate of 0.3 liter per minute. The concentration of CO2 in the incoming ventilation air is 300 ppm or 0.03%. It is desired to hold the concentration in the room below 1000 rpm or 0.1%. Assuming that the air in the room is perfectly mixed, what is the minimum rate of air flow requirement to maintain the desired level? This is the equation. You will need the QT because QT is what you are looking for, and put in all the values. N is the generation of carbon dioxide within the room. CS and CE are, let me check back again. CS and CE is the average concentration of contaminant within the space, and CE is the concentration of contaminant of interest in the entering air. So put in all this value and you will see that the rate of air enter or leave the space is around 15 cubic feet per minute. Alright, sometimes you can use mixing effectiveness to reduce the risk of sick building syndrome. So you have this equation as well. EOA equals to Q0 minus Q0E divided by QO. QO is rate of which the outdoor air is taken. QOE is rate of unused air which is exhausted. QoS is the air supplied to the space. R is the fraction of return air, and S is the fraction of the bypass or supply air. Alright, example. For a given space, it is determined that due to poor location of inlet diffuser relative to the inlet of air return, that means that the return air and the supply air is misplaced. Right, misplaced when they are designing this space. And due to partition around each workspace, that means you have a lot of partition, cubicles, you have cupboards that are blocking this airway. About 50% of the supply air for space is bypassed around the occupied zone. So that means the air return and air supply is very far from a space where people are sitting in a room, a lot of cupboards, so they bypass it and bring into the place where a lot of people is sitting. What fraction of outdoor air is provided for the space are effectively utilized as the recirculation rate is changed from 0.4 to 0.8. You will use this equation, right? R, which is the return fraction of return air, you have 0.4 to 0.8. You have all the values, right? All the values. S is the supply air for bypass stratification, is 0.5, which is 50%, right? And 0.4, 0.8 is this one. So you get for R is equals to 0.4 V fraction of outdoor air is 0.625 or 62.5%. That means outdoor air must be 62.5%, or if it's 0.8, it's 83.3%, right? Now, space distribution. Space distribution is when contaminants exist in the only small portion of the conditioned place. It is desirable to minimize mixing of air within occupied zone. This may be accomplished by some degree of displacement ventilation. Purpose is to remove or dilute airborne contaminants. So the assurance standard must be included temperature, humidity, minimum outdoor air requirement. If it's a residential house, CO2 levels below 1000 ppm, the outdoor air supply is around 15 cfm per person. Right? Air cleaning, gas removal, absorption, molecule dissolved in the air reacts with a substance called applied in the life support system. We have physical absorption, that means maybe adhesive or molecules to the of solid absorbent, or aka the filtering methods. Right, filtration. Filtration is a removal of contaminants from the air. Both particulates and gaseous contaminants can be removed. But since gaseous filtration is rather a specialized subject, we will not discuss it here. Right? Filtration will not be discussed here heavily. Particulate filters work by having particles trapped by or adhere to a filter medium, maybe a HEPA filter or any kind of filters that they use to trap contaminants. The actual performance of a filter depends on several factors, including particle size, air velocity through the filter medium. The faster the better, but it must trap more contaminants. Filter material intensity, what kind of material you use at the filter, and the dirt built up on the filter that sometimes need to be washed chemically or just using water. Right? So that's all for this week. We have talked about the comfort and health of human beings inside a space. And if you have any question, please don't be shy and ask me on Telegram. Alright, so that is a very quick one. I think so. There's not much calculation, just a few equations needed to be used. And thus I conclude week 6, comfort and health, indoor environmental quality or air environmental quality. Okay, so I'll meet you in our meeting. And if you have any question, just like I said, please send your Telegram questions towards me. Okay, until then,